Cool, thank you. So for those of you who don't know me, my name's Martijn Verburg. I help run the London Java User Group. I run a whole bunch of global programs for all of the Java user groups around the world, including Adopt-to-JSR, Adopt-Open-JDK, and we're involved in MicroProfile and Jakarta EE. And we most recently have started actually building Java ourselves. So there's now an actual Java called the Adopt-to-Open-JDK Java. And we've done this to make sure that you can get your nice Java for free with long-term support for at least 4 years. For those of you who have missed it, Java is now being released every 6 months, which is a brave, new, fun world for us to all live in. Even the LTS releases, that'll be Java 11, Java 17, Java 23, you can do the rest of the maths yourself. The security patches, etc., will only be backported for 6 months. If you want an LTS release from Oracle that will last longer than 6 months with security patches, you will have to pay Oracle. Or you will have to go to an alternative vendor and find an OpenJDK binary, which is line-for-line code identical to what Oracle produces, because everything is now completely open source. So you now be able to go to vendors like Azul, Red Hat, ourselves, so the Adopt-Open-JDK community, which is backed by IBM, Red Hat, and a bunch of other people, as well as the user groups. So if you have any questions or concerns about this, because this is a massive change for you as a Java developer, you can come and find me afterwards. But this talk is going to be about how you survive migrating to Java 9, now Java 10 because it just came out, and soon to be Java 11 in September. Who's having fun with the 6-month release cycle already? I know I am. I'm called the Diabolical Developer because I make fun of vendors. Does anyone here work for Oracle? No, we're safe. Good, I won't get sued this week. Happy days. And I run a company called JClarity, which most of you will have never heard of. We use machine learning to try and figure out why your Java program is going slow. So we find your bottleneck for you using machine learning. It's a lot of fun. And I hired some really smart people to figure out all the math for me. And I just run the company. Highly recommend it. This is what I'm going to cover. How to download and get your Java. How then to run your application. And note here, we don't try and build your application yet, we just try and run it. Step 1. Then compiling your application. Then having a look at the wider ecosystem and seeing which frameworks and which libraries actually work with Java 9 and 10. The answer is not all of them do. And some other major impacts that you might get from running Java 9. Little things like the default garbage collector changing on you, which has a significant performance impact. And lastly, I will cover a tiny bit about whether or not you should move to the module system or not. And to make it really short for you who don't want to wait to the end and want to leave now and have more cake, the answer is no. But I'll go into detail as to why. I'm Dutch born, but I grew up in New Zealand, hence my accent is Kiwi. And so for non-native speakers, I can be a little bit difficult to understand. So if I speak too quickly, or if you no longer understand my English, wave your hands like a wounded giraffe, and I will hopefully slow down for you. The other curious observation I'd like to make, and as a Dutch-born person I really love this, I was out at Dragor over the weekend and I saw the beautiful bridge going out to Malmö. And then my Danish friend explained to me that the beautiful bridge was on the Swedish side, because the Swedes have to show the world how impressive they are. And the Danish, of course, went, that's a terribly stupid idea, we'll just build a cheap tunnel instead, which I think is quite brilliant. So that to me now is my takeaway of the difference between Swedish and Danish culture. So let's get on to this. Downloading and installing your Java 9 or 10. You can go and get it from Oracle still. Now, there's a subtle differentiator when you go and download Java from Oracle today. You are now actually able to get 2 separate choices. You can download the Oracle JDK. This comes with an Oracle license. And if you want to, you can buy some commercial support and pay Oracle a lot of money. Or you can actually get an open JDK binary from Oracle, which is line for line identical for Windows, Mac, and Linux only. If you're doing ARM64, ARM32, if you're doing Lego Mindstorms or anything fun or interesting, then you cannot get a build from Oracle. So that's one thing to notice first. You can still get it via your Linux distributions, so you can do apt-get update or your yum whatever. Be extremely careful to check what repository you are getting your Java from if you use this mechanism. There have been several times where the Debian distributions, for example, have put out known corrupted or bad or compromised OpenJDK builds, and as a naive developer, you might just go and download them because you trust the big companies, right? And you trust their security teams. Just remember, security teams are made up of people just like you. And I'm sure you've all made a mistake or two in your coding along the way. Azul actually provide a very strong OpenJDK derivative called Zulu, which is very well built, very well tested, and I think has a more generous licensing condition than Oracle has. Red Hat, if you're on Red Hat Linux, definitely go with Red Hat. They've produced an excellent binary for a very long time. And last but not least, the new community effort, which is about 300 people are currently working on this build farm, from the London Java User Group, Java user groups around the world, IBM, Red Hat, even some Oracle employees are involved to try and again produce this community build of Java. So that's how you can get 9 or 10, lots of different ways. Next step. Look at this list very carefully, and I'll explain it. Do not run Java 9 or 10 from within your IDE. Okay? Do not try and compile your application yet. Do not try and use Maven or Gradle, because you're going to run across all sorts of problems before you even get a chance to run your application. The very first thing you want to do is just go Java -jar, throw it at your application. Or if you're running in an application server, you just want to start up your application server with the Java 9 runtime, and then watch it break horribly, because none of them work. It's great. Except for maybe Wildfly now. Yes, Wildfly works. There you go. What you will find is some JVM warnings when you run Java 9 on your application for the first time. And I'll go into detail as to why you're going to get those warnings and, luckily, what to do about them. Another small warning about the Java 9 and 10 installers, especially if you're on a Mac, it will borg your machine. Remember, this is Oracle, and Oracle just wants to take over everything. And so if you install Java 9, you will mysteriously find your Java 8 and 7 and 6 goes missing. Now, they are actually still on your Mac, but the installers have just moved paths and other nasty things to make sure you can't get hold of them. So you have to do some fixing. I assume, is everyone here on a Mac? I assume only half. Windows? That's who's supporting Microsoft. It's Denmark. Now I understand. Anyone here running a Linux desktop? Yes, my heroes. Fantastic. That's what we like to see. This is my presentation laptop, by the way. I do have a real developer laptop. It's a Linux box. So you want to make sure that you set your Java home and path appropriately in whatever shell scripts or startup scripts that you have. Or you can use two tools, either called Jabber or SDKman, in order to manage all of the different JDKs on your environment. And this will help you stop the evil Java 9 and 10 from taking over your entire system and breaking everything. And it can be as simple as this. This is the shell script I wrote. My engineers like to laugh at this because it's quite poor. But basically it just swaps between the various various Javas on a Mac. And I can go use Java space the number of the Java I want to use. One key thing about version numbers, I'll get to you in a second. Java 1.7, Java 1.8, Java 9. So not Java 1.9, and Java 10 as well. So if you're using command line tools, etc., the version numbers are going to be 9, not 1.9. So it's another key differentiator you're going to find. Yes, you had a question?
Well, I have a comment. You have tenth to manage your versions on Mac, and you have SDKman,
Yep, SDK man is excellent, and JEnv is, yes, another useful tool in this space. So you have lots of options. Public service announcements. You do not need to modularize your application to run on Java 9. Okay, Java 9 still has a class path. Java 17 will still have the class path. Java 23 will still have the class path. Java 50 whatever will probably still have the class path. It will never go away. Okay, so even the chief architect of Jigsaw, Mark Reinhold, has said, as much as he hates to admit it, the class path will always be there for you. So don't worry about changing your application to run it. If you have any of these flags in your startup script, your Java 9 JVM will crash. Poof! Your application will not run. That's helpful, isn't it? We like this. This is all to do with old versions of garbage collectors that were deprecated in 8 and removed in 9. So if you use these, then you're in trouble. These following flags will just give you warnings in 9 and 10, and in 11, poof, your JVM will blow up again. So if you do see these warnings, you actually need to do something about them. Again, these are all flags to do with the way that memory management works in older versions of Java which have been replaced. So perm space was replaced by metaspace in Java 8. And the two bottom ones are about how you print out your garbage collection log. And again, those details have changed in 9+. Java 9 also removes some things. The Java database that used to come with Java, gone. HProf, for those of you who dig into those details, gone. Visual VM, who here uses Visual VM? A few handful of people. You now have to go to visualvm.net to go and get it. So it's a standalone product now that you have to download. Okay, so it no longer comes with Java. And then in Java 10, they got rid of more. So if you use any of these options or if you use any of these tools, they're no longer there. So you don't have them. And now the fun part. The first thing you will get, assuming you've got an application of any reasonable size and you're using some libraries which are not the most brand new versions of themselves, you'll get these runtime access warnings. And in a nutshell, what they're saying is that with the new modular system, Java itself has been modularized. And they've put in very strict boundaries as to which module can see which other module. And they deliberately have restricted a lot of modules for security reasons. So if you remember about 3 years ago, it was the year of Java security vulnerabilities, and every day there was just some catastrophic Java security bug. So they've actually gone and fixed a lot of that by using the module system. This is a good thing. Unfortunately, a lot of your existing libraries are trying to access those forbidden internals. So for now, in Java 9, you get a warning. However, in Java 11+, chances are your program will just fail because it can no longer call that method or call that class. So this is a warning you should not ignore. Luckily, the warnings are actually pretty good in terms of the English explanation. So Java libc helper is trying to use reflection to get access to the get file descriptor method. And that is, going forwards, is going to be a no-no. Now there's going to be lots of different ways you can fix this, and I'll go into that shortly. What you want to do to prepare yourself for the future is add these flags to your Java runtime, to your startup script. And the one you want is either a legal access debug, if you're really struggling to find the full stack trace or method profile of the library that's being naughty. Or you want to use a legal access deny, because that will then, instead of giving you a warning, it will actually stop your JVM from running, which is what the future behavior of Java is going to be anyway, so Java 11+. So you might as well start fixing things now. So, you started your application on Java 9, you've got warnings, or it doesn't even work. What do we do? To fix those warnings, you've got a few options. Either upgrade the dependency that is causing the problem to the version that is not causing the problem, And you'll have about a 50 to 60% success rate with this. So quite a lot of popular open source libraries have been upgrading. The one I've showed you here, whoops, that one, which is Jython. Jython has actually put out a release which has fixed this particular problem. So if you're using Jython, just upgrade to the latest version. Easy. You can also fix your own code if it's your own code that's doing this naughty reflective access. Who here uses reflection to access something they shouldn't? Ooh, lots of you. Good. You've got some code to fix. It'll be fun. The other painful option which you're going to have to persuade your bosses or your engineering managers is that if you really want to get the third-party library fixed, chances are you're going to, and if it hasn't already been fixed, chances are you're going to have to go fix it yourself and contribute that patch back up to the upstream project. Who here uses an Apache Commons library of some sort? Apache, wow, all of you, fantastic. So if you've seen the mailing lists over the past year, it's been hysterical. Because a lot of these libraries haven't been touched since Java 5 or 6. And all of a sudden you see this mail coming on a mailing list which has been quiet for 3 years. Does anybody know where the original maintainer of this library is? We need to upgrade it to Java 9. And then a week later, the maintainer comes back from holiday and says, wow, I didn't even know this mailing list was still going. Java 9? I didn't even know Java 6 had come out. And then the fun really starts as you watch them painfully migrate from Java 6 all the way through to Java 9. So I think about half of the Apache Common libraries have been fixed, but the other half are still out there in limbo. So as part of your kind of project plan to move to Java 9 or Java 10, you need to tell your managers that there's going to be a cost of you working on upstream open source projects, which will be involved. If you really, really, really have to, and your boss is saying, no, we are an evil boss, you must not contribute back to open source, and we have no time to fix things, you can use the --add exports flag. And this is effectively a workaround. You're telling the security manager, you're telling the module manager that, yeah, I know I really shouldn't be doing this, but just let me do it anyway. You have to find out what the module names are, which you can find out in the module-info.java file inside the JDK for that particular package or that particular module. So in this particular case, Java management is the source module name, sun.management is the package name. So notice module name is different from package name for those of you who have not run across the module system yet. And then you can name the exact modules you want to have access to. And for the lazy, you just say all unnamed, I don't really care, I'm in a hurry. That's the fastest way to do things. But please, 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 if you do this, make sure you open up a big ticket in your Jira or your GitHub and say, technical debt alert. We've done something very bad here. It will cost us millions of kroner in the future. Make sure you say millions, because then it scares your bosses properly. If in particular you're trying to work around the reflection issue that I showed earlier, so you've sort of got two different types of runtime access. You've just got a normal Java method call, like a virtual dispatch call as we like to call it. So just a regular, class.method name, call this. If you need to, if that's blocked from you in the JDK, you can use add exports. If you're being really naughty and you're using reflection to dive into a module and call something that which you're not supposed to be doing, you can use --add opens. And it works exactly like the --add exports, but this is specifically designed for reflective access. If you are using reflection, you really need to go away and have a look at, from Java 7 onwards, there is a whole bunch of new APIs for you to do reflection-like calls. Method handles, method types, method references. So have a very good look at those APIs and see if you can do the same thing using those secure type-safe APIs as opposed to using reflection. But if you absolutely have to, you can use at --add opens. Is everybody clear on that? That's yeah, I see nods. Good. Okay, you can always grab me afterwards if you got confused over that one. Next fun breaking change. This was a weird one. We have a whole bunch of very commonly used, well, maybe not Corba, but hey, libraries that are both inside Java EE and inside the JDK. This was just a bad idea from the very start. Never mind. They are included in Java 9. They are physically there when you download the JDK. However, when you start the JDK, or you start the JRE, the Java itself, they are excluded from the module path, from the internal module path of the JDK. So they're not made available to your application by default. So they're physically sitting there, but if you start the Java, those aren't there anymore. Okay? So they've been set as deprecated. Corba has actually already been removed, and I think the others are going to be removed in Java 11, which is coming out in September. So what you need to do is you need to find the replacements outside of the JDK itself for these packages, for these libraries. If it's Corba, write your resignation letter, hand it to your boss, go find another job. If it's the other four, we have some solutions. If you're using Java 9 and you really want to access that module, which again, remember, is packaged with Java 9, but it just doesn't seem to be available, you can use this ---- add modules flag, which tells Java, no, I really know you've got this thing packaged inside of you, just go reference it, please, and it will go and find it. You can also find the third-party jar in Maven Central for the particular package that you're looking for. So there are third-party jars for Java transaction, activation, and XML out there. So you just have to search for them. Use mvnrepository.com to execute your search, and you'll be able to find the jar file that you need. And you just put that on your class path like you normally would, right? So you either add it to your Maven POM, or your Gradle build file, or your Ant IV build, or your shell script, if that's how you build. Does anyone here still build using shell scripts? Yes, one person, always one. So again, you can either use ---- add modules for Java 9, but remember that these modules are going to go away in 10 or 11, so don't rely on this. Or find the jar file, put it in your class path. Or if you're being really brave and you have modularized your app, you need to find the jar file and add it to your module path instead of the class path. I'll talk about that a little bit at the end of the session. All right. So people are hopefully quite clear on that. It's quite common for people to use XML bind, etc., inside their applications. Or it's very common for your application server to make a call to that particular library. So things like, WebLogic and WebSphere just don't start. So that's why you need to take care of those. The way the date library is formatted and held inside Java has undergone a subtle change. So if you're working with any sort of special character sets, like, I know, Icelandic, Japanese, Chinese traditional, you may find that all of a sudden your code stops working. This cost one of our customers, a Japanese bank, a really small sum of money. So small that it would probably buy this entire university 2 times over. It was not a good day for them. They're still trying to work out whether the government's going to bail them out or not. If you want to see what your code is going to do in Java 8 before you migrate, you can set the Java locale providers there. If you say JRE then CLDR, that means you will have the behavior of Java 9 for your date libraries, the way it's formatted internally. So you can test this out beforehand. Then the next thing you want to do is write down this really long URL. Just kidding, I'll put the slides up. There is a couple of places which I have put a best effort basis in terms of saying which open source libraries are actually Java 9 compatible and safe to use. So you can actually just copy and paste that bit.ly link, and it will take you to the Quality Outreach Wiki, which OpenJDK runs, which tells you what those libraries are. So hopefully once you've done all of that, you will actually be able to run your application. Usually only takes 2 or 3 days of pain and suffering. It's not too bad. And the next thing you want to be able to do is compile your application in using Java 9. And here we have some more fun things. You're no longer allowed to use the underscore. Who here likes writing Java 8 lambdas? Yeah, you all use underscores to indicate your void parameter that you don't care about. Yet you're not allowed those anymore. You can get around this. If you use 2 underscores, that is perfectly legal. And I've seen some fun code bases where people have just used underscore art in their source code. The use of minus source target and release, minus source and minus target is effectively going away. You want to use the new minus release flag. And what they're saying is that officially they're going to support Java for 3 versions back. They've just changed their mind on this because they've realized 3 versions back only means 18 months, which is not very much. So it's likely going to be 6 versions back, so every 3 years. So if you have, for example, Java 11, you should be able to compile back to Java 6 for now. But they keep changing their mind, so you need to be careful here. JDEPS is a tool that came with Java 8, and it's also part of Java 9. It will tell you which one of your dependencies are about to cause you compile time problems. So again, if you've got a Java 8 code base, you can use the JDEPS tool or the Maven JDEPS plugin, run that over your code base and get a bunch of warnings up. And you're going to see warnings like this. It's quite similar to the warnings you saw with the reflective access. Basically, you're trying to compile against something which is either been locked away by the module system for security reasons or just isn't there anymore. Right? It's been taken away. So this is kind of one of the first times that Java has really dramatically broken backwards compatibility. Right? Almost every single project I've ever run across for all of our customers, if they try and compile under Java 9, they always run across one of these. So something always breaks. And what this is basically saying is that that particular package is no longer visible because the module system has gone and hidden it away. So we're going to have to try and find a way of getting around this problem. So let's go see what happens. Let's go see what we do. And it's exactly the same as the runtime problem. You find the third-party library that you're depending on, and you go and upgrade it. Or you patch your own code to use an alternative, or you contribute upstream to the library. Okay? But there are some other ways of getting around things. Just like with the runtime warning, you can also use --add exports to get access to a method which the module system has said you previously weren't allowed to have access to. So again, exactly like the example before, the module name is java.desktop. The long thing with Nimbus at the end is the name of the package. And then I'm not really sure what module the class is I'm looking for in, so I'm just going to say all unnamed. And by saying that --add exports, Java desktop, blah, 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 that would resolve that compile problem. Okay, so if you get a compile problem that's inside the JDK itself, then you can use --, exports. If it's a compile problem in a third-party library, you usually need to go and upgrade it. As I mentioned previously, the JDEPS tool helps you find all of these instances before you even start compiling. And this is probably the most user-friendly tool I've ever seen Oracle produce. It's actually really nice. It tells you you were using this internal API which has now been locked away, but look, I'm going to tell you exactly which new API to go and use. Wonderful. The problem is, Oracle forgot to have a one-to-one mapping for all of the APIs they took away. So sometimes you get some options on the left, but no options on the right. Oh dear. Does anyone here use sun.misc.Unsafe? A couple of people, yes. Lots of your toys have been taken away. They're temporarily putting in a public API to the same functionality, but that won't last. So if you're doing interesting things with Unsafe, then you will need to find new ways of doing it. And again, they don't always have a viable replacement yet, which is the hard bit. So as well as running JDeps, you can also run another tool called JDepiscan. This also comes as part of a Maven. There's also a Maven plugin for this. This will tell you all of the APIs that are currently deprecated. And when they say deprecated in Java from Java 9 onwards, they actually really mean it. They are going to take stuff away from you. Okay? Because we now have the module system, they believe it is actually quite safe now to take away things, because users can actually develop their own modules if they really want to keep that functionality, and you can put your own module into your application. So we may one day see Java util date or Java util calendar disappear. Wouldn't that be nice? Hopefully one day it'll happen. So yeah, you can see that it just puts pretty nice output, tells you what's deprecated, and you really need to go away and find the thing to go and fix for that. Right, so we can run our application. We can now hopefully compile our application. And now we can actually finally open the darn thing in an IDE so we can actually do something real with it. So do the IDEs all support Java 9? IntelliJ works perfectly. It supports Java 9 and 10 perfectly. It even supports Java 11. It was even so far ahead that with Java 11 they actually had raw string literals implemented, and then Oracle said, oh, it's actually not going to make Java 11, so they had to switch it off. So they're really good. Eclipse, it works mostly. I have it working for Java 9. Java 10, I still have Eclipse doing weird things. And then you get the really big pop-up saying OSGI plugin error and about 5 lines of like plugins and stuff. Yeah, that still happens too often. Any NetBeans people? Oh, a few of you, cool. So when they finally get around to releasing NetBeans 9.0, that will work. It works really nicely. If you can get the preview from Apache now, and it will work. And of course, Vi or Vim or Emacs will work perfectly, because that's what real developers use. So we won't worry about that. That's fine. Okay, so on to the build tools. This is always a fun cultural experience. Who here uses Ant? 2 people. Maven. Ooh, Gradle? Oh wow, it's half-half here. Interesting. So strange. Half of you use Microsoft Windows to develop on, yet you use Gradle. Strange behavior. I do not understand this. All right, so Maven. If you are going to use Maven, you must upgrade to the very, very latest version. You must also explicitly update all of the plugins to the very latest version. If you're using a multi-module project or some sort of parent POM or a bill of materials, I highly recommend that's where you set the plugin versions. Otherwise, things like the Surefire test will fail, you won't be able to create sites, the animal sniffer plugin will magically break, and a whole bunch of other stuff goes horribly wrong. Okay? So even if you upgrade to Maven 3.5.3, the default plugin versions that 3.5.3 comes with do not work with Java 9 or 10. Okay? So you must update all of the plugins manually. JClarity's parent POM is now something like 600 lines long, and it's just plugin versions declared everywhere. It's really fun. Can't say much more about that. Gradle, since Gradle 4.7, it just works. Now note here, when you say source or target compatibility, again, it's not 1.8 or 1.7, which is what you'll be used to putting in. It's either 9 or 10 directly. Your builds will also be slower under Gradle. Gradle used to use a whole bunch of really interesting tricks inside the JDK itself in order to compile really rapidly. Now, of course, Oracle has blocked that off using the module system. And the Gradle folks said, can we please have access? And Oracle went, tough luck. And so Gradleware are still trying to find a performant workaround for the tools they used to have access to internally. So you may find if you've got really large Gradle builds that unfortunately you will slow down. Ant has worked forever because it's awesome. One other little trick when it comes to building or compiling Java 9 code, if you want to use a specific Java 9 feature, but you just want to deploy one jar file to your customers, and they're running Java 8, you can use this thing called the multi-release jar. In your meta-INF under versions, you can put in version 9. You have an exact copy of the class that you have just under your source main Java if you're a Maven user, for example. And you put in your Java 9 versions. You'd have simple class.java, and inside that particular class you might have a specific Java 9 API call, something like the take while in streams, for example. And if that runs on a Java 9 JVM, it will look through the meta-INF and it'll find the Java 9 version and it will run that one. If it runs on a Java 8 JVM, the Java 8 JVM has no idea what that meta-INF thing is, so it just ignores it and uses the Java 8 version instead. So that can be quite a nice trick to use if you're worried about having to deploy 2 different versions of Java because Java 9 no longer supports things. Now on to the next section. Major library and framework support. Will it blend? This is fun. If you're a Spring developer, hooray, everything works. If you're a Java EE developer, tough luck. And that includes Jakarta EE, as it is now known as. So that whole stack just does not work on Java 9, basically. Very little of it does. RxJava, yes, fine. Vertex, the very latest version they just put out 2 days ago, yes, so that should now be a full green tick. And the rest of those libraries there are now all okay. But again, you need to move to the latest version, which has its own cost in terms of migration. As I mentioned earlier, Apache Commons, a lot of their stuff still breaks. Hibernate, I'm sure you're all very pleased to know works. And yes, JUnit and Jacoco, fine. Altools, fine, obviously, that's my sales pitch. Who here still uses a web or an app server of some description? Oh, not so many of you anymore, that's good. Okay, well, Glassfish doesn't work. WebLogic, this is really funny. Oracle's WebLogic doesn't work. The irony. IBM's WebSphere doesn't work. The very latest version of their Liberty, Open Liberty as they call it now, kind of works. JBoss or Wildfly or the thing they now call Thorntail, if you're using microprofile, it works. So basically, if you're running an app server, don't migrate. It's a pretty simple rule of thumb. Next little section, performance issues with moving to Java 9. Java 9 changes the default garbage collector from the parallel collector, or serial if you're running a weird combination, to the new thing they call G1. G1 is designed to stop you from having those really big long pauses, the ones that stop your entire JVM and pisses off all your users. So it's designed to do that, and it mostly does it. But it does do a lot more housekeeping in order to do that. And that housekeeping means that your throughput, so the number of transactions going through your application per second, especially if you're something like a messaging application, that can dramatically decrease. So you just have to be aware of this quite significant change in performance characteristics. So you've all written performance load tests, of course, for your continuous integration and continuous deployment environments, which you all have. Yes, and your pre-production environment, which is a clone of production. Yes, good, lots of nodding, excellent. Because remember, in the brave world of Docker and cloud, we can have environments that look exactly the same. So we should be doing that. So that's something you just need to really take good care in. Compact strings. This is actually a benefit in Java 9. If you are processing a crap ton of JSON or XML, which is what most of us seem to do today, then if you are only using the Latin 1 character set, so you're not using any funny characters and funny languages, then your strings will actually get automatically compressed, which can save a ton of space. So you may find that you'll be able to reduce the size of your JVM, or you'll actually be able to process more JSON and more XML inside your JVM. So that's a nice bonus. Outside of that, like every new version of Java, there's just hundreds of tiny little performance fixes, which generally speaking means your Java will be faster. What other warning do I need to give about this? Oh yes, who's running Java in a Docker container? Are you all aware that Java and Docker lie to each other for Java 8 and 9? Yeah, okay, so one person nodding up there. So what Docker reports as its CPU and memory, etc., and what Java reads that as, they're not one and the same thing. Okay, so the Docker container actually reports the full underlying operating system to Java. So Java goes, woohoo, I get the entire host memory and the entire host CPU. And then when Java runs, the Docker container goes, nope, you only get a single core, and nope, you only get 256 mega RAM, not the 4 gig you thought you were getting. And so Java just behaves horribly. Other things to watch out for with Java and Docker containers. The G1 garbage collector uses a lot more native memory. So if your Docker container gives you 256 meg of memory, and you give it a 256 meg heap in terms of the size of the Java you're giving it, you add the native memory on top of that, and all of a sudden, you've blown past your 256. And everything starts paging and swapping, and you start impacting the other containers on the same host, and it all goes horribly wrong. So you need to make sure that when you size your Java inside a container, that you give it enough room for the G1 collector to use the native memory space. Java 10 partly fixes this, so Java 10 does detect what the Docker container is actually telling it in truth. And Java 11 is adding a whole bunch of APIs where you'll be able to get metrics from the container as your JVM is running, so you'll be able to understand how things are running. How am I going for time? Okay, not too bad. Right, last but not least, so we can run Java 9, we can compile it, we've got an IDE that works, we've thrown away our app server because none of them work, and we figured out our performance issues. Now do we actually start using Jigsaw? So you need to proceed with a lot of caution. The problem is that if you modularize your application and you start running on the module path, everything that you depend on must also be on the module path. So all of the libraries, all of your dependencies must also be modularized. Now, a lot of projects have done this little trick called automatic naming in their modules. So they've basically just said, our entire big fat jar, which is log4j, is one module. And we're going to give it the module name of log4j. So they don't really modularize it, they just say this is the one big fat module. So that's how some of these libraries are getting around it. Other libraries have not even done that, and therefore if you depend on it, your application won't run. Okay, so you need to chase all of your dependencies all the way down to the bottom, make sure they've all got a modular path version of themselves, which for most applications today is pretty bloody rare, right? Because you're normally talking about hundreds of dependencies. The IDEs sort of help you, but not really. IntelliJ, again, is the best. And Maven and Gradle, they can build applications for the module path, but they don't give you really nice support for it yet. And one of the things we're looking to do is to actually crowd fund some developer time to actually go and help fix Maven in particular, so it can support this better. If you really have to modularize your application, then I recommend these two books. The one on the left, the O'Reilly book, is personally my favorite. That will guide you through all of the ins and outs of modularity, including little things like split packages. So you're no longer allowed to have the same package in two separate modules. So just think about that. So think about how often even in your Maven modular project or your Gradle modular project, how you have exactly the same package name in two separate modules. Verboten in Java 9. That's right, you have to watch out for things like that. So some early things you can do. You can modularize your app using Maven, JBoss modules, or OSGI, that'll help. Make sure you code interfaces. That split package problem I talked about, there is a tool for this, JSplit package scan. We're turning it into a Maven module at adopt-open-JDK, so that should be coming out soon. And if you do all of those things, then you can start your journey if you really want to. But I would say as of now, until most of the popular libraries in the Java world modularize themselves, it's just not worth starting. And with that, since I'm just about out of time, are there any questions? Or is there stunned silence? Who now wants to migrate to Java 9? One person does. Has anyone actually done it yet? Yeah, you have? Did it take a long time?
Took 2 days, and yeah, I ran into most of that.
Yeah.
The only thing I couldn't get a new version of was the XP schema compiler, but I can see the poor guy is working on it after
Yeah.
2 years. He owned it because a lot of people sparking him.
Yeah.
So I did it mostly to make a small JDK for Docker.
Okay, yeah.
Strip out, all the
Strip out all the modules. Yeah. So he raises a very good point there. One of the advantages of moving to Java 9 is that you can actually deploy the part of the Java runtime that you want with your application using tools like JLink and JPackager, and actually deliver to your customers or to your hosts a much smaller Java runtime bundled with your application. So it has a much faster startup time, smaller footprint, all those good things. It's something my company does as well because we deploy our application on all of our customers' hosts. So that can be a nice reason to migrate. Any questions? Yes, up the back.
With the flags that kick the technical debt down the road, how long are those still going to allow you to get around those problems? I mean, at what point do you have to say that you have to fix?
So,
That you would, like the Nimbus example that you gave.
yeah. So the question is, how long can I get away with using _add exports or --add opens? At the whim of the Oracle architects is the answer. So they first of all said that they would officially remove access in Java 11, which is coming up in September, but they have already started to backpedal from this idea, and I suspect that's because the internal Oracle people who have built massive Java Oracle products haven't actually fixed their stuff yet. So that probably means you'll get away with it until Java 17, I think. So maybe 3 years, which seems like a long time, but in Java Enterprise land, that's actually not that long, yeah, as you know. Cool, and I think I'm out of time, so I'll stop there, and you can find me outside if you have any questions. Thank you.